Alright guys, this video is for Algebra 2, 7-4 solving logarithmic equations. Essentially what we're going to do today, we're going to use our switch rule and start with that to solve logarithmic equations. So basically what your first step here for the first one is going to be for solve log base 36 of x equals 3 halves. You're going to apply your switch. So we're going to go to exponential form, so 36 to the 3 halves power equals x, and then you're going to work the left hand side from there. So rewrite 36 as 6 squared to the 3 halves power equals x, which leaves you with 6 to the third since the 2's cancel out, and that leaves you with 2 16 equals x. So it's a pretty simple process as long as you know how to work with the numbers like we have been. Just changing the bases, it's not too bad a problem. So we go the other way now, so 9 to the 3 halves power equals x. So 3 squared to the 3 halves equals x, so 3 cubed. And so x equals 27. Went a little fast through that, but hopefully that makes sense. It's pretty much the same stuff that we have been doing. Next slide's going to have a question for you. We want to see if you can apply it, so if you need to go back and watch this, do so. But here's your first question, solve log base 16 of x equals 5 halves. Okay, so hopefully you guys got 1,024 whenever you solve it that way. I haven't say this from the beginning, this is going to be a fairly short video because it's a fairly easy lesson. We're going to do these problems here where you get it down to a switching property. And then we're going to go do another type. But before we move on, I want to say this. Pay attention whenever we're moving on to the next lesson when you watch the next video, because this is one of the types of problems that you're going to want to try to get the next section's video problems down to. So next time, you're going to want to either look to get your problems down to one of this type, whether you switch it, or one of the next type. So it's an important base to your problems. It's kind of like how 6-4 was last chapter, where it's going to be kind of, here it is, one time try these problems, and then we're going to take this concept and apply it later on. So we won't do a whole lot of these problems after this lesson, and you'll understand why once you get through the video. But getting them down and understanding that this is the type of problem that you're looking for is important to understand going forward. So we're going to make sure that we know that. The property we're talking about that I mentioned earlier is called the property of equality for logarithmic functions. It's a long title, and it's a pretty basic property. Basically what it says is if you have an equation with logarithms to the same base, what you're taking the logarithms of has to be equal. So for example, if you have log base 5 of 8 equals log base 5 of x, log base 5 of x equals log base 5 of 8, then x has to equal 8. So if you have just single logs on both sides of the equation, you can cancel them out basically and leave equal what you're taking the logs of. So x equals 8. You can then take that and apply it to your problems. So here, since we have log base 4 of x plus 3 equals log base 4 of 2x plus 1, we can go ahead and cancel out them log base 4s and let it be x plus 3 equals 2x plus 1, and then solve that equation. You get 2 equals x. The only thing you have to do with these is go back into your original and make sure that your log is positive. Okay, I don't know if I mentioned that yet to you. You can't take the log of a negative number. It's undefined for it. So you have to make sure that when you go back and plug into here, you get positive. Okay, these numbers could be negative. As long as you go back here, it makes them positive. So if the log itself, if what you're taking the log of is negative, that's when you throw out the solution. And then we're going to have one like that in a little bit. So 2 plus 3 is 5, and then 2 times 2 is 4, plus 1 is 5. So both times you get log base 4 of 5, so this one checks out. I'm going to go ahead and ask you to do this one on your own. Hopefully you can figure this one out. Okay, so hopefully you got x equals 3. And once again, you go back and check. Both times you should get 7. 2 times 3 gives you 6 plus 1. And 3 plus 4 gives you 7. So x equals 3 works for the solution. Let's show you one where something funky happens. So here we have log base 2 of x squared minus 4 equals log base 2 of 3x. So same thing, you're going to have both logs cancel out. So you're going to be left with x squared minus 4 equals 3x. Trick to this problem is you got to recognize what type of equation you're left with. In this case, it's a quadratic. And the way you solve quadratics is by making it equal 0. So x squared minus 3x minus 4 equals 0. And then hopefully this guy factors. In this case, it does. So you set up 2 parentheses. Go x minus 4 and x plus 1. Then you split them up into 2 cases, so x minus 4 equals 0, x plus 1 equals 0, so then add 4, so x equals 4, and x equals negative 1. Have to go back through and check both of them, so we do so. So 4 squared gives us 16, 16 minus 4 gives us 12 over here, and 3 times 4 gives us 12 here. So both times with 4, you have log base 2 of 12. So 4 checks out. But then when you take negative 1 and you plug it in, you're going to get, you should get negative 3 here. You also get negative 3 here. So they're equal, but even so, since you're taking the log of a negative number, that when you try to evaluate that, it's going to give you an undefined expression. It's going to tell you, you know, it's not possible, not in the domain. So x equals negative 1, we toss out. Okay, so the only solution we have to this equation is x equals 4. So you remember, it's not if this number is negative. Okay, most cases it will be. It's whatever makes this top part up here negative. That's the numbers you throw out. Alright, so the next one here is going to be for you guys. The next two actually are going to be for you guys. I'm going to show you the one, show you the work after this, and then pop up the next one, have this, and have you work that one. So this one's up first. You got log base 300 of x squared minus 15 equals log base 300 of 2x. Okay, so you should end up with two solutions of negative 3 and 5. When you go check them, negative 3 you toss out because it's negative right there. 5 you keep because it works out both times. So again, you'll occasionally come up with some factorings throughout here. A little sporadic with those, not a bunch, just a few are here and there. So make sure you know what they are and when they show up, okay? Once again, this last one here is also for you guys to try out and see what you get. You got log base 12 of x squared minus 7 equals log base 12 of x minus 5, or x plus 5, sorry. Okay, so hopefully for this one, you have x equals 4 and x equals negative 3. So, like I said, 4 obviously works, but negative 3, when you plug it in, you get 2 both times. Okay, so that's positive. So it doesn't matter if this number down here is negative, staying on the negative 3. This can be negative. It depends on when you plug it back in here. Is this negative? So if this is negative, if this quantity is negative, that's when you throw out down here. Rarely, but possibly, you could be throwing out positive numbers down here because they could make the tops negative also. Okay, so it depends on what you get up here when you plug it in, not what it results in down here. So make sure you keep that straight. That's like the biggest sticking point of the video itself. Hope it was an easy one. Hope it was pretty simple. The homework for this one is going to be page 480, 8 through 19.